Let's talk more about atoms. So, after Dalton postulated his atomic theory in early 1800s, we had to wait for almost 100 years for the next discovery, the discovery of the first subatomic particle, the electron. And it is credited to Sir Joseph John Thomson in 1897 through his work on cathode rays. So in his experiments, he used so-called Crookes tube, which is a glass container in which two electrodes are separated by vacuum. So in these tubes, cathode rays were generated here on this part of the tube. And as you can see, if we have an electric field right here, anytime when you change the charge on the electric field, you turn it on, you change the charge, you will see that the cathode rays are going to be deflected towards the positively charged plates. Right? Can you see it? Positively charged plates, and the rays are deflected into that direction. So, with this, he showed that all atoms contain teeny tiny negatively charged subatomic particles, which are our electrons. Now, what's interesting is that Thomson actually called these particles corpuscles. And he knew already that atoms are going to have an overall neutral charge. So he proposed that these corpuscles were distributed in a uniform sea of positive charge. He imagined it kind of like if the electrons would be like raisins in a plum pudding, just like it's shown here. So the model is called the plum pudding model. The only difference between the plum pudding and Thomson's model is that in his model, he imagined that the electrons were constantly moving around. Thomson also determined that the negatively charged particles are significantly lighter than the positively charged particles by measuring the mass to charge ratio of the electrons. And the charge of the electrons later was determined by Robert Millikan in his oil drop experiments.
So Rutherford thought
That the electrons are uniformly distributed in the sea of a positive charge. So then Ernest Rutherford came up with the so-called gold foil experiment. So he took a very thin gold foil, which is shown right here, and he started bombarding it with alpha particles. He didn't really know what alpha particles are at that time, but we know that those are positively charged particles. Now, if Thomson's model is correct, we would expect that these large particles just simply go through the atoms without hitting anything, right? Well, what actually happened is Rutherford discovered that there must be something inside the atom that is really dense, okay? And that is the atomic nucleus. And that atomic nucleus deflected some of the alpha particles that were bombarded at the gold foil. So, with this, he came to the conclusion that most of the mass and the positive charge of an atom is concentrated in a teeny tiny fraction of the volume of an atom. And he assumed that this is the center. Rutherford postulated that an atom has a very small and dense positive center with the electrons around the outside. So basically, this means that if we have a center that is teeny tiny right there inside that circle, and the electrons are kind of just somewhere outside, most of the atom is space, it's empty space. So if you imagine that the nucleus is the size of a pea, then an atom would be a size of a football stadium. So this is basically just the parts where the electrons are distributed. When I imagine atoms, I think of the Flash, the fastest man alive, and he's kind of just zooming around where the seats are in a huge stadium. And he's not going in circles all the time. There are some spots where he likes to hang out where the food is good. Okay, that's just my funny imagination. So, what are in the nucleus? What type of subatomic particles? We know that the electrons are around the nucleus, but inside the nucleus, we have actually protons, which have a positive charge, and neutrons that are neutral. Okay, so in this figure here, we can see two protons and two neutrons in the nucleus. And to make the atom neutral, because you have two protons with +1 charge, if electrons have a 1 minus charge, how many electrons do you need to make the atom neutral? So a net charge of 0. 2 protons plus 2 electrons will give you a net charge of 0. Okay, I hope this makes sense. We continue our discussion on atoms of an element in the next video.